till before these new agentic AIs or AI agents was something that automation executed. Now the agents are the ones that are able to decide for themselves, right? So that in an agentic system, what's more differentiated is the context that you can actually provide to the agent. It becomes even more fundamental to supporting an agentic system, and almost like a central, to the architectural nervous system, of an organization. Governance needs to go into production and not just, it doesn't end, till the time that the system is designed so that someone will pick it up, build the system, and it's done. No, it's not possible. Have human in the loop where required, because that's what's going to give them the maximum business value, maximum agility. Enterprise architecture used to have, annual review cycles, traditional kind of governance structures and so on. It has to be continuous.
Hello and welcome to the Enterprise Tech Talk podcast. I am your host, Saumitra Kalikar. Now, for decades, enterprise architecture has been about designing deterministic systems which operated predictably, followed well-defined organization flows, and had very clear scope boundaries. But in the age of AI, this is changing. We are seeing emergence of agentic systems now, which not only can reason, but can also act autonomously. And that raises an important question as to if the systems we are designing are inherently non-deterministic, then how are we going to design the overall technology ecosystem and how are we going to govern that? But that is the focus of today's conversation, enterprise architecture for agentic systems. And to help me unpack this important topic, I am joined today by Gautam Nadkarni. Gautam is the Chief Architect and Head of Tech Advisory at Wipro, Australia. He is also a member of Forbes Technology Council. Gautam, welcome to the podcast.
Thank you, Saumitra. Glad to be here with you.
Gautam, your professional journey has been interesting. You have worked on various technology domains, starting from service management to infrastructure, cloud, architecture, and now so maybe to get started, can you provide a brief overview of your professional journey and how you eventually landed in the world of AI?
Sure. Thanks, Samudra. It's a very good question, and the way that now you put it, right, it just kind of things that looking now, you've been into, your career, for a very long period of time. But look, I think, to be honest, I think I started off my career with into data warehousing, and some of the technologies and so on, right, and working for one of the medical and healthcare customers, for US. But from then on, I think, every few years, I think, I've got opportunities to move or choose paths, that came across to me. And personally, I believe in the philosophy of, going as it goes, so taking it as it goes. Fortunately, I have got opportunities, which were very interesting, challenging, that provided opportunities for learning and so on, right? And that's how typically I made my choices in terms of moving through the different either technology or even some of the roles as well, right? Not purely, sticking to, one or the other. So it's been a very good journey, very learning, learn it kind of a journey, over through the so many years, right? With data warehousing to service management, as you mentioned, to infrastructure consulting, got into some of the platform engineering parts of it, got opportunities to build some digital banking platforms, on the cloud. Then moving into, from an architecture overall standpoint and so on and so forth. And now, coming to the AI part of it, right? So which is, pretty much pertinent. And again, my foray as well, into the AI world has predominantly been more in terms of the opportunities that I'm getting to work on, right? Because it's a very challenging era that we are into from an AI perspective. So which is where it's very exciting to learn about, so many new things and, things that are fundamentally changing of the typical, technology paradigms that we've known all through so many years. And I think even going forward as well, right? I think, I would choose, the way that I see it is try to keep it simple, as long as there is some interesting work to do, interesting people around you to kind of work with, that journey becomes actually very interesting and enjoyable.
Yeah, that's a great backdrop, Gautam. So maybe we can start with a grounded conversation. Um, see, this whole term concept around agentic systems um, is becoming more and more visible and more discussed within the business organizations, and rightfully so. But it also has a bit of mixed interpretation, right? So when you talk to business leaders and IT leaders and try to explain what an agentic system is, how do you approach and explain that in a much more simplistic and practical way?
Sure. I think, so look, in the most, simplistic way, if we have to define, and if you look at the journey that has exponentially grown over the last about 2.5 to 3 years in the AI space. Look, AI has been there for quite a bit of time, but it's only, I think, gotten off just in the last about 2.5 3 years. After the large language models, became much more accessible to everyone at a cost that's actually not accessible to everyone, and so on, right? So, which is where that capability was actually available now, and it's getting more and more important today because there are a lot of organizations, almost now 80%, in the last 2 years, if you see, organizations that have now using these new AI models in one way or the other. And that's and that has grown from almost, I think, where it was about 25-30% about 2.5 years ago, to almost 80% plus now, in Q1 of 2026. But all of that, right, I think the just shows that, look, the adoption of this fundamentally changing technology has been extremely high, and the curve is very, very steep, as compared to any previous changes that we have seen. So what is it that's making this different, to answer your question, right? um, in most simplistic terms, right, so agents are systems that are able to do either of these four things, right? One, are they able to actually perceive what's happening in their environment, right? So either in terms of the data that they're being fed, or events that are happening, or visuals that are getting presented to them, or whatever that they're hearing, right? So that's where essentially our AI agents that can actually perceive the environment. The second type of agents essentially more around reasoning, where the agents are able to not just understand what they are perceiving, but able to actually make a judgment call on what to do with that particular perception that they have gathered. Um, the third is essentially, now that they've actually perceived, they have actually reasoned, understood, what to do. They have now the capability to actually act, right? So they can actually act through tools, through APIs, through other systems, and take that action. And not just actually stop there, but also then adapt further, learn from what the outcome has been, and then get into a loop where they actually perceive, reason, act, adapt, and it can go on into a continuous loop, right? So in the most simplistic terms, AI agents are systems that are actually built with underlying large language model intelligence, if I were to put it in very very kind of layman terms,
Mhm.
that are very highly intelligent, that are able to have a logic which is following neural logic, which is like the way that our brain works, and able to perceive, reason, act, and adapt, right?
Mhm.
So if you were to really look at it, that look, the automation till now that we knew, the automation till before these new agentic AIs or AI agents, was something that automation executed. Now the agents are the ones that are able to decide for themselves, right? So that's where the autonomy comes in.
Yeah, yeah. And you already differentiated, explained well as to how it differs from the traditional automation, because automation as a concept is not new. We had different ways of automations, and this is a bit different. But just to clarify a few points for our audience, how would you differentiate agents from, let's say, microservices and other automation technologies in the past?
Yeah, it's a very interesting question. I think, a bit technical in nature as well, depending on the audience and who would look at it, right? But essentially, if you're looking at how are today's AI agents or Gen AI or agentic AI different, fundamentally different from automations or workflows or microservices, all of the systems that we know of today. Um, it would be easier to understand it from their behavior in terms of how different their behavior is from the traditional, or not, I shouldn't say traditional, whatever that we know of automation, workflow, microservices before the new AI foray
Mm,
to now into the agentic systems, right? How are they different? And if I were to really kind of simplify it, maybe I would actually put it in five different dimensions. Um, so the first dimension essentially is the execution path of how that particular system is executing whatever it's supposed to do. Right. And in this case, right, so the traditional automation of workflow or microservices, they would typically have predefined, deterministic paths, right? So you have defined or programmed it in such a way that it will behave in a particular manner, and you will be fairly certain that looking that's how you have programmed it. An agentic system is something that the execution path that it actually follows is more emerging, based on the context that it is provided and planned at the runtime, right? So it will decide in terms of what and how I should behave, while it's actually being executed itself. So one, that execution path is, fundamentally different. The second part, if you look at it for any system, is where do you think that the system can fail, right? So from a failure mode perspective, typical traditional automation workflows, microservices, they would the failure mode would be typically, from a predictable standpoint, right? So where either it would time out, that look, there is no response from it, or there would be an exception, a scenario that it has not come across, and that's the reason why it will terminate, right? So in which case that particular transaction or an action or execution that automation is supposed to provide, it will fail and stop, and it stop at a particular point. Whereas if you look at agentic system, then the failure mode for an agentic system typically it's a bit more probabilistic. So it might still continue to operate, right? But it would actually either hallucinate, it will actually create stories, right? Or it would drift, from the level of confidence that it's supposed to provide. What's the exact, required output, right? Because there is a inherent intelligent, judgmental system that's actually running behind it. So that probabilistic behavior around failure being from hallucination and drift is different uh, with respect to traditional automation systems, which is more timeout or exception based. The third is essentially around testing, right? So how would you test a typical automation system versus how would we typically test today an agentic system, right? Very, we've been now for past so many years, right, been used to do, your unit test, system test, integration test for whenever these systems are getting developed, right? Your automation workflows, some microservices, APIs, etc. For agentic system, however, I think the testing needs to be a more about evaluation. That look, what's the level of confidence of the output it is getting produced? What's the level of accuracy that it is actually getting produced, right? You'll have to constantly simulate to understand, whether the system is drifting or not drifting. You'll have to do behavioral testing in terms of those AI agents in different scenarios. How are they behaving? Because there is no, standard input, standard output, kind of scenarios, right? Because the behavior of the system would depend on what's the context you're providing at the input, and based on that, even then, the output would be typically different in two different scenarios, right? So the testing is different. Um, the fourth is essentially where it comes with the state that the systems follow, right? So whether traditional IT systems, they're either stateless or session bound, in terms of having a particular state, with a particular, set parameters that are there relevant at that point in time. Okay. But however, agentic systems, they have a memory that actually goes, across a time horizon, right? So in terms of how do you track that, that's also a state in terms of that it has a memory of its own, and it could work either ways, right? I mean, sometimes, in most times, it gives the context, but in certain times, if you want it to behave certainly differently, then you would need to ask it to forget what the previous memory was to be able to really get the required output that you need. And the last fifth is essentially about the governance, right? How would you govern agentic systems? Your code reviews, change management, typically are your governance mechanisms for traditional IT systems. Whereas in case of agentic systems, what you would need to do is, you need to continuously observe their behavior. You need to continuously evaluate the um, how that system has been built, how the underlying LLM models are actually being released on a frequent basis, and basis that, is the system kind of changing and so on. So you have to continuously evaluate both before production and after production as well in terms of what's happening with that system.
Yeah.
So and so very sorry, a long-winded answer, but I think if I were to summarize in a way, that typically, a microservice, would typically answer what exactly it is doing, right? What exactly we need to do. A typical workflow would actually help us to execute how essentially a particular process needs to run. Whereas now the newer systems agents, in addition to the what and how, it actually gets a why as well, that it's able to reason and then decide in terms of how the what and how have to be performed.
Okay, that's good, Gautam. You are clearly, I think, articulated that uh, agentic systems. This is not an incremental change in the way automation has done in the past. It is really a fundamental shift, completely, right? And that raises some important implications on how enterprise architecture needs to be done in the future, because in traditional ways systems, we have the technology of platforms, the systems which are very much deterministic. They follow very well defined workflows, as you also mentioned, right? But and they had very clearly well defined integrations, right? But in the agentic system, the as you said, there is a inherent intelligent agency. There is emergence of mechanisms and protocols called like MCP, which determine dynamically which are the tools they should be using for what kind of use case, etc. Right? So that raises important question as to when you talk about how we do the enterprise architecture traditionally, identifying systems, identifying integration points, pattern, etc. What are the shortfalls in the way we used to do enterprise architecture, and what kind of gaps we need to fill in to make enterprise architecture ready for the agentic systems in the future?
Yeah. I think you're right, absolutely, Samudra, because till now, as architects or even as overall IT professionals, we've been used to working with deterministic systems, and typically these words deterministic and probabilistic, have now started to become more prevalent. Deterministic being that, look, you have programmed a system such that there is a stated out input, and then based on that there will be a stated output, and you can be reasonably confident based on how you have programmed in terms of what the input and output could be. Whereas probabilistic is that, look, the system has an intelligence of its own, so it will take the input, but along with the input you would have to provide as much context as you can provide to that system as an AI agentic system, and then based on that it will decide what kind of output is relevant. So the outputs as well could be probabilistic in terms of whether it would be this or that, right? So there is a bit of probabilistic nature in there. And for that, right, so if you look at typical traditional enterprise architectural approaches, there are a few areas in my mind where typically things fall short of, and I think they're fast kind of closing the gap. But I think given the steep learning curve, we are still in a catch-up mode, right? So first one, I would think in terms of some of the architectural frameworks that are there today, that usually enterprise architects use, and they all assume fairly deterministic systems and structures, constructs that are relevant from deterministic systems, right? Things like you would have capability maps, application portfolios, integration patterns, all of them. They assume that, look, given an input X, the system will produce an output is Y, right? But as I explained, I think when it comes to now the newer AI, Gen AI, Agentic AI kind of systems, that assumption is no longer good, right? Because based on input X, depending on what other context that you give to the system, the agent will decide in terms of what the output is. And the output could be either y, or it could be y minus 1 or y plus 1, right? So in these scenarios, what's the best practice from an enterprise architecture framework that to be utilized in such a frame of reference, right? So that's one part. The second is from a standpoint of the static blueprints of technology and architectures. More and more, all of the systems are actually becoming more autonomous, right? So where previously you did have blueprint where you've got an X system and a Y system, and both you have to program it that look how are they going to talk to each other. In this scenario, the X agent and Y agent, if there are two different agents, they can themselves determine in terms of how they want to talk to each other and how they want to behave with each other, right? So that's a runtime behavior. So when we think as architects in terms of how to build such systems, how to manage systems, how to make sure that these systems um, are able to produce the outputs that's within a required range, um, that's something different, right? We're not used to that kind of a construct and that kind of a way of working from an architecture perspective. That look, how do we get to that state? It's really very practically and fundamentally changing architects' behaviors on the ground, and that I think architects needs to be very conscious about it. The third is essentially around from some of the change management of the code or the systems, right? So for agents, as I said, I think the behaviors can actually shift, can drift um, for multiple reasons. An agentic system, right? Either the underlying model that was used that changes. Either you use a different model, or there's a newer released model, version of a newer model. All of these things, right? So based on that, the system behavior will change, or it will change based on the context that it is provided, or the guardrails that it has actually being constructed around it. All of these would change the behavior of the system, even if you don't change the code, right? So how do you kind of manage and construct all of these things together so that it's not just about the code, but it's more about the behavior in terms of what we want that particular agent to do, and the various surrounding parameters that are changing alongside with it.
Yeah. So just an adjacent question to that, Gautam. What does it mean then to where we used to do architecture governance, right? Because as the determinism has gone away, right? There is less assurance to architects as to what the output would be, right? And most of the governance in the traditional sense has been around getting that assurance, making sure there are less risks around outcomes, etc. Right? So what are those implications on architecture governance?
Yeah, pretty much. I think, and there are so many dimensions to this question. To be honest, but look, again, I think going back to what I said, right? I think the core difference of the probabilistic or autonomous systems of agentic AI that we have to deterministic previously systems that we've been used to governing is the same thing. That look, a system behavior previously used to be very predictable in terms of the time, and then you kind of monitor that for deviation. Whereas in this in an agentic world, what would happen is you can only make out what the agent's output is when it's at actually runtime, when an actually output has been generated, right? So that's a fundamental change of the context in terms of what's changing, right? So which is where, as a architect or as enterprise architects, what you need to focus on is not just about uh, the actual agentic system being designed or the actual agent system as such, but the architectural governance also has to shift a bit to the left in terms of, before that agent being live, what kind of evaluation of the pipelines of the context that it is being provided, what's the evaluation before that, as well as once the actually agent is in action. Architectures also have to govern the runtime from a monitoring perspective to make sure that the agent is still behaving within acceptable limits, right? So which is where I don't know how to explain this, but essentially, in a way, today for architects, right? Typically enterprise architects, you go to a governance forum, you would say that, look, fine, I think, all of these design parameters are met. Now it's approved to deploy, right? Because once you even deploy it, still you can't say that, look, okay, fine, now given that I have designed this way, this is how it will operate, right? You would still need to look at that particular agentic system in production to keep track of it, that whether it is actually operating within bounds, or if it's not, if it's drifting, then again go back to it and make sure that you're making changes and tweaks to the parameter. So it's like almost a continuous architectural governance that you require in today's agentic AI world. If I were to sum up the architectural governance for agentic systems and how that's changing, a very good practical layman's terms that we could actually correlate to is that enterprise architecture, right? It's kind of today moving from cartography to an air traffic control kind of system. If you were to put it into an airlines kind of scenario, an air control or an airlines industry scenario, right? So where the enterprise architecture is moving from cartography to air traffic control, where cartography typically used to be designed focused on designing actually maps, drawing maps, okay, but now the architects, right, the maps are just not relevant, because they have to kind of more manage the flight paths in real time to know that every aircraft can replan its own flight, change its own path mid-flight, right? It's the same way agents behaviors can change actually mid-flight, right? So you can't actually just release into production and then rely that, look, they are going to actually behave exactly what they're expected to.
Let's dive a bit deeper into the core architecture patterns which are emerging when we talk about agentic systems, right? And in particular, because we don't talk about a single agent, we actually talk about multiple agents, right? And those multi-agent systems require different patterns, right? How you can architect those, all right? So there are different patterns which have been talked about and emerging, right? One is of an orchestrated pattern, right, where one agent actually can orchestrate the workflow, and there are dedicated sub agents which have specific responsibilities. Then there are swarm patterns, right, where it's a swarm of agents which are actually doing their own unique delivering their unique responsibilities, right? When you look at the patterns across the spectrum, how do you what's would be your guidance to business organizations as to how they should approach thinking these patterns, where federated patterns make more sense versus a swarm of agents?
Sure. Thanks. Samantha, I agree with you. Look, I think there are some broad, about 2-3 patterns, as you rightly mentioned. When using, today's, the new age kind of AI systems. The most simplistic one, first one essentially is just using a single agent, right? So, and plus, some kind of tools with it. It's kind of typically most applicable in, a very singular task or a specific activity that we would want the agent to do, right? So, and typically it works in activities that are maybe a bit more regulated environment, and you need to know that, look, you're able to broadly control it properly, in which case you just have a single agent, so that you have got parameters that you can properly control and monitor. So for example, you could have a finance agent that does just the invoice reconciliation by itself, or you could have a legal documentation agent that's actually churning out legal contracts based on whatever context that it has been fed with and designed with, right? So very single agent kind of structures, right? So that's where it's kind of typically used. And most organizations, not just regulated, but many times when you're actually starting on an agentic AI or an AI journey, in a lot of sense, a lot of organizations, that's where they start here, right? Having single agents, different point solutions that they want to use. The second is the orchestrator or supervisor pattern, where you've got an agent orchestrator. You have got like these, multiple different agents, right? So for example, if say there is a customer service orchestrator as an agentic orchestrator, and it would have multiple agents as underneath it that it will have to orchestrate, right? Things like first, about perception, right? It will a single agent that's maybe hearing what the customer is saying, or it's actually reading what the customer is actually writing and understanding what the context is. The other agent could be based on that context, try and extract some information from the backend systems or from the memory that the chat or the agent has, right? That could be the second agent. Third agent could be, either do some kind of a action for what's actually required for that particular customer, right? Either extract some kind of a statement, give it to that, do some kind of refund, provide some information, or do some escalation and so on, right? So there could be multiple agents, and there's an orchestrator sitting on the top. Now, this is where, typically today is what we call as agentic system or an agentic AI, where you've got an agent orchestrator that's actually orchestrating between multiple agents, right? So, and usually it's used when you require compliance, some bit of predictability, because you're actually then decomposing your artificial intelligence into different kind of pockets so that which system where exactly is actually something that's happening, and so that's the second orchestrator pattern. Third is a decentralized swarm, or more of agent peer collaboration, where you don't require an orchestrator agent or an orchestrator to sit on top. uh, thus individual agents have instructions given to them that look, when it's something as a task that they are not the best capable to handle, they can actually look for any other alternative agents that's there in their ecosystem who can do that work, and they will actually pass on the baton to that particular agent to do that work, right? So which is like very small amount peer collaboration. That typically happens where you require very high speed, at scale, fault tolerant kind of matters. And so this third pattern is a bit more complex, typically, more used in things like, examples like, you real time, logistics, or, route optimizations, or, typically your market making, from a automated, or, autonomic trading into the markets. Those kind of use cases are where, decentralized, swarm or peer collaboration can work. In most scenarios, however, I think, where the industry is moving towards, most likely, uh, I say most likely because we don't know, and no one is able to today predict that how the whole, agentic and AI system and world is going to evolve into. But most likely, it's a today most more or less, I think, it's a hybrid of the second and the third pattern, right? Where you've got majority of the systems that have following orchestrator pattern, and some of them, would potentially follow a peer collaboration pattern or a decentralized, kind of a swarm pattern as well.
Yeah, as organizations start thinking about these multi-agent architectures and multi-agent ecosystems, there seems to be emergence of what is being called as control plane, and this is about making sure we have a right governance, the observability, the security standards, etc., all applied consistently across all the agents, right? Can you unpack that concept a bit as to what is the control layer about? What is its critical role in the multi-agent ecosystem?
Sure. Yeah, look, I think the control plane is, definitely one plane. But I think along with that, in today's agentic systems, it's important to note that along with the control plane, typically you can classify two other planes that go along with it, right? So one is your data and context plane,
Mm.
and the last one essentially is your execution plane, right? So in your control plane, typically you would, set up your guardrails, your identity and access management of that agent in terms of what all things can the agent have access to, routing of, which particular task is going to what particular agent, so all of these typically, would happen within the control plane. And even, things like, your continuous evaluation observability, or kill switches, in terms of, how to kind of make sure that, this is a parameter when you have to really stop the agent completely, right? So that's the control plane, on the topmost layer. The data and the context plane is also equally important, where, you would typically have your embeddings, vector stores, etc., in terms of, and that answers the question in terms of what does the agent know, right? And where is it getting the context from? And the third one essentially is more about the execution layer, where the agents themselves, right, who are actually executing that particular tasks, or the tools or APIs that they're invoking. So that's the execution layer, and that actually answers the question in terms of what's the agent doing, or what does the agent do. And you're right. I mean, across these, the control, data context, execution plane, around some of the APIs, tools, layers, and so on. Multiple of them that are getting evolved, even, every day, every hour that we actually speak. So, and typically, the model context protocol as well, right? As we know, it's kind of becoming a standard layer for different agents, talking to each other, or or agents talking to different tools, from a agent to platform kind of protocols to talk to them. And now it's almost reached almost some 10,000 odd kind of MCP servers, that are today publicly available, and which is where just worth noting here, because just because of the sheer scale of the MCP servers that have now come up, an enterprise architect or an architect's job also is important to understand which of those are actually relevant and secure, that we need to actually make sure that we can actually make use of into an enterprise.
Yeah. And probably an adjacent question, and probably a bit too early to be honest, I would say. But as organizations will start building this agentic ecosystem, there would be at some stage plethora of these agents, and you need to make sure that you are effectively controlling them. And the life cycle, the version controlling of agents will start becoming important, right? So, how do you see the need for agentic life cycle version management becoming more important in the future, and what are the ways organizations can control the life cycles for the agents?
Yeah, look, I think this one of the parts, from an overall so the infrastructure layer of today's IT systems, including the agentic systems as well, right? So that in a way has evolved, and it's continuously evolving, for the purpose of how do we use our existing systems to manage the new agentic systems that are actually getting built, right? So which is where, if you're looking at typically from an agent life cycle standpoint, uh, it would in some shape or form, at a principal level, still operate, like, typically that, we should have known, some of the ML ops, or, the machine learning ops, in terms of how that ML ops life cycle used to kind of operate, or even now operates, so it kind of follows a similar model, right? So which is now, I think nowadays, you've got your agent life cycle, you've got your ML ops, you've got your LLM ops as well, in terms of how do you manage the life cycle of LLMs, that are underlying the agents. But usually, right, I think they follow the similar life cycle stages, right? And you define exactly what exactly are the agents supposed to do. You build, around with the prompt engineering, integrate the agent with different tools. The third, would be around, evaluating them, in terms of behavioral test suites, right? Because the testing of agents, works differently. How do you do red teaming? What kind of hallucination benchmarks are actually acceptable, within limits? All of that's, about evaluation. Deploy them, with the circuit brokers and, rollback kind of paths, in terms of once you deploy an agent, where do you actually make sure that, look, this is something that's not acceptable and you should, kill the agent or stop the agent.
Mm.
Observation, observability of agents, even more critical in terms of evaluations in production, whether the agent behavior is drifting, just because of the way that the user is interacting with the agent, or the way that, look, something else is changing as a parameter.
Mm.
uh, Govern the agent, from a periodic recertification. Very important to make sure that, at a periodic level, it is actually recertified, republished. And then the last, from a life cycle perspective, most critical stage around retirement, because the agent has actually built context, memory, access, etc., etc. Um, from a retirement perspective, it's important to make sure that the memory is completely cleaned, credentials are, completely revoked. Anything, that's required from a auditability perspective in future, is make sure that that's kind of archived and, kept for records. So typically, it would follow, if I think, similarly, to an ML ops or an LLM ops, kind of life cycle that an agents
Yeah.
would follow.
Let's move to the next topic that I wanted to unpack with you, which is around data context and the way memory needs to be managed within agentic systems. And you started describing that a bit, but I want to unpack that further. Because one of the biggest shifts when you talk about agentic architecture is about the context, how they effectively manage context, right? That's a key differentiator. So when you talk about the new data architecture that needs to support the management of memory, management of context, etc., and how the data architecture has been done traditionally, what are the key gaps you see how it is done today, and then what are the key capabilities and improvements are required for building that data backbone to support agentic essentially the outcomes that agents needs to deliver consistently?
Sure, sure. Yeah. Yeah, look, I think there are a few foundational elements, that are critical, right? Because as we move from, deterministic systems where, the differentiator is actually your code. In an agentic system, what's more differentiated is the context that you can actually provide to the agent, right? How much crisp is the context? How much accurate is the context? The breadth and depth of the context that you're able to provide the agent is what's going to determine, and that context comes from data, right? Because and that's going to determine how effectively the agent is going to perform and the output that the agent can provide. And all of this has to be within the making sure that look also about the performance in terms of what and how the agent can perform, right? So the key part from a foundational thing that has to be different is a shift from a data standpoint is moving from code differentiation to the context differentiation that will be provided by the data systems, right? Two organizations having the same foundational model, the outcomes can be actually radically different based on the context that their agents can access, right? And that everything is now about the data, right? So which is where the data architecture becomes even more fundamental to supporting an agenting system, and almost like a central, to the architectural nervous system, of an organization, right? So which is where important note that look, the competitive mode is no longer the application code, but the contextual data layer. So to answer, I think your first question there in terms of what are some of the gaps, uh, there would typically expected to be huge gaps, right? I think your fundamental, data architectures and the data structures, data infrastructure that was previously there before the foray of agentic AI systems, that anyways has to be there, right? So because your output of the agents is going to be only as good as the data, how accurate is the data, how how clearly you're able to track the data lineage in case if there is a particular question that actually comes from an agent, and so on, right? So that fundamental has to be there on top of your normal traditional data foundational elements that we have been used to. For agentic systems now, there are more, different data capabilities that have started to move in. I don't know whether, that's what you were alluding to, but, things like, vector stores, right? Which is important for making sure that, the semantic context for what's actually required for an agent, it's able to retrieve it through the vector stores. That's how you build vector stores. You store into the vector stores the information and context that your agents would require. The embedding strategy, from a data perspective, is again more core from an architectural perspective, where a data architect or enterprise architect would need to think about how exactly my data is going to be chunked, and then fed to the agent, so that making sure that we're able to use appropriately the context windows that are available for specific agents based on their capabilities, right? So that embedding of the context and the model selection, etc., all of that would be critical, from an embedding strategy, right? So there's a second, from a gap perspective that is required. The third gap essentially is from a real-time context pipelines, right? So because the context of the organization is continuously changing, right? So the performance of the agent is only going to be as real-time and as accurate and relevant that we need, based on how much of the real-time data or whatever is happening within an enterprise is accessible to this agent, right? So which is where the things, where your systems of engagement and systems of records are getting refreshed or populated or changed, how that change is going to get propagated to the AI agent is going to have, your real-time context pipelines for the agents, and that's going to make your agent behavior um, more valuable, to the organization. So I would think A, obviously the data foundational element, B, vector stores, embedding strategies, your real-time context pipelines, are most critical.
Yeah. And another important aspect when it comes to agentic systems is the way the memory is handled and managed, right? And look, I use OpenClaw at home for my personal use cases, and anyone who has used those kind of agentic systems know how frequently these systems tend to forget about you and the previous job activities you have done, right? Um, but that is not acceptable in enterprise
Yeah.
context use cases, right? So you do need to think of short-term memories, how you manage the long-term memories, etc. So maybe that's something where you can potentially provide a bit insight to our audience as to how organizations should think of different layers of memory
Sure.
layers, and how they should architect that.
Sure. Sure. I'll try to be brief and answer in a very crisp manner, right? So
Sure.
the typical three layers, if you were to look at from a memory perspective, in context of agentic AI systems, right? So once your working memory, that within a particular single task or a single chat that we are having, the memory that it is that the agent uses, for the conversation and the context that's going on, right? So that working memory can be typically ephemeral, right? Which is like short lived, low risk, so you don't need to actually do that's how the nature of the memory needs to be, right? And accordingly you need to choose what kind of memory system that you choose for that. The second is essentially your episodic memory, right? So where within a particular session or related sessions to each other. So if you bundle some of the chats into a single particular project, then for that particular project or an episode, the agents would have all of that contextual memory, right? It would have it will store information around what did the agents just do, what is it that the user is preferring, what exactly is some of the data being actually fed by the user to this memory, to the agent. All of this episodic memory can typically be very PII heavy, right? So your user is going to feed in some of the things and so on. So which is where from a retention of the rules perspective, from a data governance standpoint, it is very important to handle it carefully, right? So that because there is a lot of contextual personal information that is being passed on to the agent. The third essentially is where your semantic memory comes through, right? So where the agent gets the organizational knowledge, the learned patterns in terms of how it's expected to behave. That semantic memory is actually common across all the sessions for that particular agent, right? So it will have carry all of it every time, all the time it will have it accessible to it, right? So that particular semantic memory is very IP heavy. You will have to access control it very critically so that which agents are going to have access to it, which are the users, and what part of that information can an agent disclose to a user. All of those controls need to be put in place, right?
Mm.
So three types of memory: short term, long term, working memory, episodic memory, and semantic memory.
Cool. Let's move to the next segment, which is around governance, risk, and autonomous systems. I think we discussed a little bit around architecture governance, but maybe in this section we can expand that a bit to understand the implication from security governance perspective, data governance perspective, then how to uplift the AI governance in the agentic context.
Yeah, in the most simplistic manner, right? Your the governing systems, for today's particularly from an architectural governance, if you are looking at it,
Yeah.
there are maybe three specific concrete mechanisms that are in place, right? Because you have to consider the main principal changes that the governance is shifting from trying to gate the change, meaning be a gatekeeper of whether what change is going to into production or not, to actually trying to govern that once it is in production, what is the limits of that behavior that is acceptable, right? So that's what the main governance is shifting, right? So which is where the three concrete mechanisms that from a governance perspective that are important. One is policy as code, right? As you rightly mentioned, all of the the security controls there, the guardrails, access that is allowed for the agent and who has access to the agent, right? So as well as the data and so on, right? So all of that has to be codified from a policy perspective, and make sure that that helps to kind of keep the agentic system behavior within the expected boundaries. The second is continuous evaluation. I think we spoke about earlier that not just during the pre-deployment testing part of it, but even in production, evaluation harnesses actually become very important because the evaluation is continuous. Continuously you need to keep on evaluating whether the agent is behaving within the specified limits or not, right? Before during testing and during production, both times. The third is essentially how to make sure that, look, which are the relevant cases where you need to put a human in the loop for sure, right? So you'll have to able to calibrate the risk, and based on that risk profile, you determine what are the kind of high risk actions, right? Things like, financial transactions or any kind of customer facing decisions and so on, that require human approval. And then, the agent at that points in times, the agent needs to hand over the control to the human, right? So that the low risk loops, they can actually run autonomously and continuously, but the high risk ones, essentially, definitely you need to put a human in the loop, right? So to sum up, three main controls, right, from a governance systems: policy as code, continuous evaluation, and human in the loop checks.
Yeah. Let's move to the next segment I wanted to have discussion with you on, which is around how agentic systems need to coexist with the legacy, the traditional platforms, etc. Because that is not going away so soon, right? You will always have ERP systems and CRMs and many other systems, right? Which so as you start building the agentic ecosystem, how do you see those integrating with these legacy platforms, etc.? What are the key standards they can follow to drive the use cases, agentic use cases?
True. Yeah. Yeah. It's a very good point. And, to be honest, I think, this whole space is evolving, right? And will continue to evolve. Okay.
Yeah.
Currently, the way that we actually, are seeing, obviously, I think, you've got AI agents, AI features that are natively available within the existing core platforms or legacy platforms by themselves, right? So everyone has embedded AI
Yeah.
into their platforms, right? So that's a one centralized platform where, everything is there and you could use that. The other, essentially, along with that, you still require some more, specific agentic systems that are there outside of the core platform, to make sure that, look, there are other things that would require to work along with the core platform, to be able to orchestrate all of those, right? So which is where you require a federated kind of an agent ecosystem, right? So this is where, typically, some of them, from a maturity perspective of agentic ecosystems, that's where typically people should, or aspire to be, or where mature organizations are, they will end up into, right? So from a centralized platform standpoint, where, you'll have, you know a single kind of a platform, doing all of the AI, versus a federated agentic ecosystem is, where you will have a mix of native AI agents working alongside with custom AI agents, and then working all of them together.
Yeah. Okay. Let's also now, as we move towards wrapping up this episode, let's talk about the path forward and how the future is looking like. Right. Um, for many organizations, they have, of course, most of the organizations by now have worked with Gen AI. Most of the organizations in by FY26 have at least started experimenting with agentic AI, right? But it's also the reality that most of the organizations have not started productionizing those agentic AI systems well enough, right? They're at the stage where they're still exploring how to now transition from pilot to now production and how the benefits, right? So the how would you what kind of advice you will provide these organizations who are just want to transition but they're still kind of struggling or exploring what is the best way to now start getting benefits of agentic systems?
Sure, sure. Yeah, look, I think you're right. And again, right, the things are changing, it's evolving, organizations are learning. We have now definitely reached, however, a stage where everyone, right, almost all organizations have realized that this capability around AI is fundamentally changing, and it is here to stay, and it is really giving, something truly, valuable, that people cannot ignore, that organizations cannot ignore. So, but there is a journey to it, because as we discussed, about this deterministic, probabilistic part and so on, right? Fundamentally, a lot of things are changing, right? So there is a change part to it. Most organizations typically, they would start with, usually take one particular bounded context or one particular use case, which might be most relevant, that will provide maximum, value from a business perspective. Either it could be a, customer service desk, internal IT help desk, or, documentation, kind of agent, or typically, chatbots and so on. That I think, where previously also chatbots are there, they're now actually becoming more intelligent with the underlying, newer, more capable LLMs, which are very, very close to, how humans interact, right? So that's a starting point usually, right? So, and that's what typically as a first starting step is called as an augmented kind of a journey, right? So you augment whatever currently the humans are doing with AI agents. The second essentially is you learn from that, and then, start to actually provide semi-autonomy to some of those agents, right? So you have model gateways, evaluations, you build some scaffolding systems to make sure that as we expand into the agentic systems, there are proper guardrails around it, security around it, access around it, because observability around it, because all of these have a different context when you look at it from an agentic system perspective in terms of how to manage agentic AI. Right? So that's the second step to actually provide semi-autonomy. And the last step essentially is really go towards agentic, AI autonomous ecosystems, right? So where you build truly agentic workflows or agentic processes end to end, right? So where that's the maximum benefit that agentic systems can provide, given the radical capability that today AI agents are actually offering, or AI is offering, right? So where you take complete a critical business process, or some of the critical business process, and start to automate them end to end, reimagining them end to end, and make sure that, look, you only have human in the loop where required, because that's what's going to give them the maximum business value, maximum agility in terms of what and how a matured agentic AI ecosystem needs to work. Okay, so that's where organizations of today moving from not having anything to do with agentic AI to moving to a very matured autonomy or autonomous kind of agentic AI operations. There are, however, I think some organizations, I'm assuming they will also start to be more kind of AI native, which are organizations newer that are getting built from scratch, completely, AI native models, that are people are building businesses around them. So that would be 100% AI native kind of enterprise systems, or even businesses that are actually getting churned up.
Yeah, yeah. No, yeah, that's well said, because yeah, I think there would be a spectrum. Yeah, as you said, there are AI native startups, then there are digital businesses which will be potentially more advanced on the AI journey, and they will have more greater risk appetite for a great experimentation, etc. Whereas there are more companies which are in the more regulated traditional sectors. They might be at a different stage when in the AI journey, and they will, the pace of getting on board on the AI, agentic AI, is going to be different for different industries as well. So wrapping up, and just a final question, circling back to our original topic about enterprise architecture and architecture teams. So what does it mean for architecture teams, for the architects for the future? How they should start thinking to now think designing agentic systems?
Yeah. Yeah, look, I think as I mentioned, and I don't know, I think I've had this multiple some of conversations with so many architects around the same context, right? And it is still a newer concept that people are, or architects are trying to grasp. Okay, because I don't think they still understand in terms of the fundamental change that architects' behaviors and expectations in terms of what's expected out of enterprise architects, right? Because they need to really start thinking away from documenting systems to actually operating them, right? Because the architectural governance needs to go into production, and not just it doesn't end till the time that the system is designed, so that someone will pick it up, build the system, and it's done. No, it's not possible, right? So because the agent is a continuous live ecosystem, so the architects as well need to think of the AI agentic systems even into production in terms of what's happening with them, and continuously be on track with it, right? So that's a different context altogether. um, Continuous evaluation of agentic systems is critical. I think typically enterprise architects used to have annual review cycles, um, you know traditional kind of governance structures, and so on. It has to be continuous, because the agentic ecosystem, as I mentioned, is a live ecosystem. It will keep changing, right? Interestingly, I think for architects, there are newer roles as well that have started to come up, right? So agent architects, AI platform engineers, AI evaluation leads, who understand that agentic system end to end from an evaluation perspective, all of these systems, right? So where typically they're not just normal, engineering kind of functions in my mind, but more, senior engineering or, principal engineering, or in a way, enterprise architecture kind of skill sets, to be able to have that maturity to make sure that you're evaluating a production system, in a proper manner. Right. So, I think, yeah, so that's what I would think. One is change of behavior that enterprise architects need to do, that the governance is no longer about um, designing the systems. It is actually designing the systems that are going to design, further behavior.
Yeah. And with that, Gautam, thank you. Thanks for your time. I think this was incredibly insightful discussion. I think there will be not many takeaways for our audience. So thanks again. And it was great hosting you.
Sure. Thank you so much, Saumitra. Likewise, it was a very educative, kind of conversation. Had a, enjoyable conversation. Thank you so much for inviting me for this session. Thank you.
If you found this discussion valuable, please follow and subscribe to Enterprise Tech Talk. And thanks for listening. I look forward to seeing you in the next episode.